This webinar is brought to you by IMarEST Houston, Gulf Coast Branch. Our speaker for today is Shaylyn Potter. Shaylyn grew up in small town Oregon, making mud pies and collecting insects. She was always fiercely curious. While studying at James Cook University, Australia in 2008, she began scuba diving, a passion that unexpectedly shaped her career path. With academics following suit to her passion, she studied marine biology at Oregon State University and has pursued a career in the marine sciences ever since. Shaylyn's interest in diverse marine and natural ecosystems has encouraged her to explore many underwater environments and travel to all 7 continents. Now, working for Lindblad Expeditions National Geographic as an undersea specialist, Shaylyn travels from pole to pole, helping people explore some of Earth's most remote wilderness areas. Though she loves all things ocean related, she prefers spending her time chasing polar summers and diving amongst the ice in the Arctic and Antarctic. Her goal is to use underwater photography and videography as a tool for education. For our global viewers, please note that this webinar is in listen mode only. Please ask questions in the Slido link provided. These questions will be read and answered by the speaker at the end of the presentation. With that, I hand over to Ms. Potter. You have our full attention.
All right, thank you very much, Christine, for that introduction. So I'm going to be chatting a little bit today about my work as a polar expedition diver and the work I do in Antarctica. This is a topic I find very important, and I'm also very passionate about it. So thank you all very much for being here. So I know she gave you an intro, but just quickly again, I'm Shaylyn. I grew up in Oregon. That's where I'm coming to you from today, here in my home in Oregon. So I studied marine science at Oregon State University. But in 2008, I studied abroad in Australia, where I began scuba diving. And it was so fascinating to see that underwater world that I never knew existed. And so I was really curious to see more. And when I came back to Oregon, I did all of my cold water diving training and dry suit training, and did my professional dive training then in Indonesia. So I'm certified as a rescue diver, a dive master, and a dive instructor. And right now I'm mainly working to use underwater videography and photography for science communication and outreach. And so it's always my goal to bridge the gap between the field sciences and the general public. And this is really important because in locations that are so abstract and foreign to people like Antarctica, imagery can really help people understand what lives in this environment, and it helps people connect to that environment. And connection is vital to conservation. And right now I'm applying to be a PhD candidate for the polar sciences, and I will get a little bit more into that later. So I work on this ship quite often. This is the National Geographic Explorer down on the Antarctic Peninsula. It's a ship-based collaboration between the 2 companies. It's not like your standard cruise ship. It's very small. It'll have 60 to maximum 150 people on it. It's, there's no casinos or fancy dance shows. It's an educational expedition. So there'll be different experts on board. There'll be ornithologists, geologists, different types of biologists. I'm on as a marine biologist, and my official job title is an undersea specialist. So I'm the go-to person for people to learn about the underwater world. And so my job duties include going scuba diving and taking some underwater video or photos, and I'll bring it back to the ship. I will do a quick edit, and that evening I will show the video footage while giving a lecture and helping people understand the ecology and the species that we are seeing in that area. So Lindblad Expeditions National Geographic has really been a leader in the field for more sustainable tourism practices. So it's been a great company to work for. They've gotten rid of a lot of their single-use items. We're trying to reduce food waste. They pay for carbon emission offsets for all the flights. And we have something called the LexNG Fund, where we raise money and then donate it to the areas where we're traveling, some nonprofits or research being done there. So we're really trying to give back to those locations we visit. The ships are also a great platform for science. As you can imagine, it's really hard to get to these remote locations globally to do research, even with grants and funding. So we're able to bring scientists on and help them collect data. And we participate in different citizen science projects. Like one of them we're doing is doing microplastic toes and adding into a global data set of that with the Sea Education Association. And I threw this in mainly for the Houston people. I thought you might find it interesting because when we're working in remote locations, it's really important for us to have extensive training. So last year, the company sent our dive team, as seen in this photo, to the Neutral Buoyancy Lab in Houston. It was really fun. This is the NASA pool. It's massive. It has 6.2 million gallons of water. That's 23.5 million liters. And so you can see we got our boat in there. We were able to practice all different types of rescue scenarios if we ever need to use them. And we got to scuba dive, which was an incredible experience because they have the replica of the International Space Station in that pool. And there were astronauts also diving on it and training while we were there. And I really value that the company recognizes the importance of ongoing staff training and they're able to provide that to us. So that's a little bit close to home to you guys in Houston, so I thought you might appreciate it. So I work with Lindblad Expeditions National Geographic globally. We have ships all over the world. I've worked in Alaska, Baja California, the Chilean fjords, the South Pacific, French Polynesia. But I mainly work in the Arctic and the Antarctic. So Antarctica is my favorite place to work. It's really captured my heart. I'm super curious about everything going on there. So that's where I'm going to focus my talk. And a quick overview of the continent. So this is our southernmost continent, but unlike the Arctic, which is a frozen ocean surrounded by land, Antarctica is actually land. So it's a proper continent, though 98% or more of it is covered by ice. And then it's surrounded by ocean. So it's one of the driest, windiest, coldest places on Earth. People might think about it receiving a lot of precipitation, but it doesn't. It's actually considered a polar desert. And what's interesting about it is that it's not owned by any one country. It's ran by the Antarctic Treaty System. So there's 53 countries currently involved in that. And it seems to currently be the world's most successful international agreement. But the countries and the treaty work together to decide what can and cannot be done on the continent. So they've agreed that Antarctica cannot be used for military purposes, nuclear testing, or waste disposal. So basically it can just be used for scientific purposes and exploration. And all of that information needs to be freely available to the public. So surrounding the continent, you can see here the Atlantic Ocean, the Indian Ocean, and the Pacific Ocean all merged together in this area. And so the water around Antarctica, we call the Southern Ocean. And there's a huge current system. It's called the Antarctic Circumpolar Current, the ACC. And I want you to remember this because I'm going to come back to it at the end of the talk. But that current is, it flows clockwise like this around the continent. And it connects all of the world's oceans. And it moves more water than any current system globally. So you can get to Antarctica from different ports, but we leave here from Ushuaia, which is the southernmost city in Argentina. And we cross this tiny body of water here, well, tiny on the map, and we end up here on the Antarctic Peninsula. But just this trip between the tips of the continents takes 2 days by sea over the Drake Passage. So that just shows you how absolutely massive this continent actually is. So I'd spend all my time here on the peninsula, but I'm particularly interested in this area here in the Ross Sea. So that western part of Australia, there's the Ross Ice Shelf here. And the US actually has a base, McMurdo base, in this area. So hopefully one day I'll get to do some studies there. So as I mentioned, the Drake Passage, 2 days by sea. Some days it can be really calm. We call it Drake Lake. This photo is taken on just an average day, but you can still see the water coming up over the bow. But sometimes it does get really rough. It can get, I've seen it been 10 meter or 30 feet waves or higher and smash out some windows on the ship. So it can be quite intense, but even if people get seasick, I tell them it's definitely worth it to make the trip because when you get there on the other end, It's just absolutely incredible. Antarctica is this otherworldly place, and I can't always describe it. A lot of times it's just a feeling you have. You look out over the ocean and you just see miles and miles of emptiness, just of ocean and ice. And it's such a vast environment that it makes you feel very small and humbled. In this photo, we see a tabular iceberg. So it used to be part of the ice sheet, and it has broken off and is now floating in the ocean. I would estimate it's probably 100 feet high or so above the ocean, but that means below the water, it goes hundreds and hundreds of feet below. So the tabular icebergs, if they're bigger than 10 miles across, we will name them. And they can be huge. They can be bigger than US states or European countries. And the largest one, I think, was B15 and about the size of Jamaica. So if you're interested, you can get online and look up tabular icebergs, and you can see the satellite tracking of them. But yeah, Antarctica has stolen my heart. I really look forward to a future of studying there. It's just a place of great beauty and wonder. I want to show this. This is often what it looks like around the peninsula. Like I said, it's land. So you can see the peaks sticking up and the ice sheet and the glacier coming down. So the highest peak in Antarctica is Mount Vinson. It's about 16,000 feet or close to 5,000 meters. So you can see the kayakers in the photo just for scale. And just really beautiful sunsets. I initially went to Antarctica to see wildlife, but I think I keep going back because of the ice and the light. That far south, you have nearly 24 hours of daylight. And so the sun's really low on the horizon, setting for hours and hours, and then it'll barely dip below the horizon just to have a beautiful sunrise for more hours. And so we get these stunning light shows. But this 24 hours of daylight in the summer, of course, it's dark in the winter, but this 24 hours of daylight is one of the factors that make it a productive ecosystem that's able to host an abundance of wildlife. So if you remember, I said that that current that runs around Antarctica is pretty turbulent. The Drake Passage is turbulent. There's a lot of wind action stirring up the ocean. There's upwelling near the continental shelf. So it's bringing vital nutrients from the ocean depth up to the sunlit surface. So all of those factors combined make it really an ideal environment for a huge phytoplankton bloom. So phytoplankton are those small plant-like organisms that photosynthesize and make up the very base of all oceanic food chains. So plankton are to the ocean what grass and terrestrial plants are to us on land. So they're very primary producers. But fun fact, actually the plankton and the phytoplankton in the ocean produce more than 50% of the global atmospheric oxygen. So that's the oxygen we are breathing every day. So they are producing more oxygen for us than the trees and the plants, and the trees get all the credit. So I think phytoplankton are wildly underappreciated. So the phytoplankton are the base of the food chain globally in all oceans, but the Southern Ocean is particularly known to have really thick algal blooms, these phytoplankton. And we see that with the killer whales, because if you think of killer whales in all oceans worldwide, they're black and white, but often in Antarctica, they are black and yellow. And that's not their skin color, it's just from the growth of diatoms, the diatoms and the phytoplankton on their body, it actually colors their skin. So this abundance of phytoplankton allows for large swarms of these krill. The krill feed on the phytoplankton under the ice, and this is the Antarctic krill. The species name is Euphausia superba. It's one of the largest species of krill globally. It's about 2 inches, which is quite big compared to other krill. And this tiny animal, either directly or indirectly, supports all of the wildlife on the entire Antarctic continent. So it's absolutely a staple food source. So what kind of animals do we see? Well, a lot of penguins. People often travel to Antarctica to see penguins, but they're quite noisy and kind of stinky, so I don't see the appeal so much. But penguins will come to the Antarctic Peninsula to mate and breed during the summer. But it's important to remember that they are marine birds, so they do spend most of their life at sea. Sometimes we see them on ice floes like this, and it's currently estimated that there are around 12 million penguins in Antarctica. We also see different species of whales. This is a minke whale coming up by our boat. It's very curious, so it came to check us out, swam around us for a while. And killer whales. So here's 2 killer whales by our little Zodiac. I really like this photo because the huge environment really dwarfs the whales. We also see blue whales, humpback whales, beaked whales, southern right whales. So there's many different species. And for the pinnipeds, we can see Weddell seals and crab eater seals. We just told this one a joke, he's laughing. And the fan favorite, the leopard seal. And of course, there's also many different species of seabirds. These are Cape petrels resting on the water, but the Southern Ocean hosts many different species of albatross, including the wandering albatross, which is the bird with the biggest wingspan in the world, which can get up to 3 meters or 11 feet across. So, we see these animals on land, we see the penguins on land, the seals hauled out on land, but it's really important for us to remember that that's just a tiny, tiny fraction of their life. Most of their life is spent living in the ocean. So they don't feed on land. And because of that, we consider all of Antarctica to be a marine environment. And this is a little video I want to show quickly of humpback whales feeding. So they feed on krill. And you can kind of see here, you can see there, it looks like a little ring. And what they're doing is bubble net feeding. And they'll go under the water and they'll blow a ring of bubbles around a swarm of krill. And that just basically corrals the krill. So when the whale comes up to eat it, the krill cannot disperse past those bubbles. I'm just going to press play. So you can see them blowing the bubbles, a little bit turbulent looking, and then you'll see the rostrum, the nose just peeking up over the surface. It's actually not terribly exciting to watch from the surface, but just trying to picture what's happening underneath all the chaos with the krill. But these humpbacks don't actually live in the Southern Ocean year round. They will migrate down from South America or Australia, New Zealand, and they will come down to the Southern Ocean in the summer to feed. That's a really long trip. It must be around 5,000 miles. So that's incredibly energy expensive, but it shows you that it's worth the trip, right? There's so much food that it's worth losing all that energy and migration to feed there. So really the take home message I want to get across by showing you this food chain is that though the conditions seem harsh, and they are harsh to us, right, in the Antarctic, it's worth the animals migrating there or adapting to this environment because of the abundance of food offered there, because of the abundance of the phytoplankton that leads to the abundance of the krill, and then it can support literally millions of animals, including the largest vertebrate in the world, the blue whale. So we know the Southern Ocean is really abundant from what we see on the surface, but what lives on the seafloor? Is it also abundant? If so, what does it look like? So these are questions I really like to answer, and I do that by scuba diving. I was trained as a scuba diver, or a polar scuba diver, sorry, in 2015, and have been diving in Antarctica ever since, and I really just can't get enough. And maybe many of you have gone diving on holiday, and you go to a dive shop and you usually hire a dive guide and they tell you, you can go to this site or this site. These are the conditions. This is what you'll see. And it's not like that at all in the Southern Ocean. So we call it expedition diving. And there's no books or guides or anything to tell us where to go or what we're going to see. So we get to make all of the judgment calls, which is actually a lot of the fun. So we'll use the ship's bathymetric charts. We'll read the tide tables. We can look at land and try to predict what it's going to look like under the water. We watch how the ice is moving. So we use all these different tools to help make a call about where we want to dive. And we're diving in such remote locations that it's possible that no other person has ever been there or has seen what we are seeing ever before in the whole world. So that makes it really exciting, and it's really motivating for me to keep doing it. It makes you feel a little bit like an explorer. So this is a common scene we'll see with all that brash ice in the water. I would never ever dive close to a big iceberg. It's very dangerous. I see people doing it online sometimes and it makes me very anxious. They should not do that. But getting in around this ice, this small brash ice, is fine. But the water in the Southern Ocean is the coldest liquid water in the entire world. So it can get to -2 Celsius or 28 degrees Fahrenheit. So that's below the freezing point of fresh water. And I tell people those numbers sometimes, and they're like, oh, that's not very cold. They're like, that's the coldest water in the world. But I think they are comparing it to air temperature, which, a freezing point in the air is not terribly cold. But because of the heat capacity of water, you will actually lose body heat to water about 25 times faster than you would lose body heat to the air. So just like you might get cold in your winter coat outside, even with all of my dive gear on, I definitely get cold while I'm diving in the Southern Ocean. And I'm primarily a cold water diver. I dive all up along this west coast of the US, in Alaska, and up in the Arctic. And cold water is always more challenging diving in than warm water. But Antarctica is really just that next level of challenging, even compared to the Arctic. Diving in water that's at the freezing point is much more manageable than diving in water that's 1 or 2 degrees below it. So yeah, it's just that couple degrees make a huge difference. And of course, when we're diving in these conditions, we need specialty gear. So the first thing I need to wear is a dry suit, and that's what I'm wearing in this photo. I had this suit custom fit for me, which is great, and really important that it fits well and I know it well. So it's different than a wetsuit, because in a wetsuit you get wet, and in a dry suit, if it's doing its job correctly, you will stay dry. And it's been pretty good. I usually stay pretty dry. And so I'm able to wear different layers of clothes underneath to help me stay warm, because the dry suit itself isn't insulated. It's just basically a plastic bag. And you can see here on the chest right there, there's a chest valve, and there's a hose that will come from my scuba tank, and I'll plug it into that chest valve, and it goes into the suit. And so as I'm descending into the water column, I'll be pushing on that chest valve to add air into my suit. And so what that does is number one, it helps the suit from squeezing really tightly on me at the depth, or the pressure at depth, but it also adds a layer of air around my body, so then I'm not going to lose body heat to the surrounding water. And the second piece of equipment that I find really necessary to be in polar water is this called an H valve. So if you have been diving or seen dive tanks, you have, the tank in the back, and it usually just has one valve attached to it. And then those valves have these hoses that come off to the mouthpiece, the regulator that you can breathe through. But since we are diving in water that, again, is below the freezing point of fresh water, it is possible for these valves to freeze. And then we have something called a free flow. So they're designed to fail safe, we call it. So if it freezes, it won't stop giving me air. It'll just keep giving me air, a lot of air, which I also don't want. So if that happens, I will need to turn off one of those valves. I'll have to take the mouthpiece associated with that valve out and switch to my second system. It's actually not that hard to do, to switch the mouthpiece at depth. We are very well trained to do that as a professional diver. You start doing that, your first day of diving. I've done it a million times, but the first time I did it in the Southern Ocean, it was really weird, because within minutes of being in that cold water, your lips go completely numb. And so when I took the mouthpiece out and put the new one in, I couldn't feel it going into my mouth. So it was very strange. But this doesn't happen very often at freezing. It's not a huge concern. We just like to have this redundant system just for a safety backup. It's always better to be safe than sorry. All right, I'm going to show you this gearing up video. So this is me putting the suit on. You can see I'm wearing long johns. I'm put a second layer on, and I'm actually going to put on a heated vest. It has a big battery pack, and it's able to keep me warm on the dive. It's awesome. And you can see I put another layer of warm clothes on, and then my dry suit. So I have a lot of layers on. And you can see that there are booties attached to the dry suit, so my feet stay dry. I have gloves on, and then I have a latex seal around my neck. So the only thing that's exposed to the water is going to be my face and head. I have to wear a weight belt just because the suit is so buoyant or floaty. So I wear about 30 pounds or 14 kilograms of weight. And then I set up the tank with my vest and the regulators and all of it together. I've never weighed it, but I imagine if I were to stand on the scale with it, I'd weigh an extra about 100 pounds or maybe 45 kilos. So it's really heavy. I wouldn't want to walk around with it too much. It takes a long time to gear up, maybe half an hour. By the time you're done doing this and you have all the gear on, you're sweaty and you're definitely ready to get in the water. So finally, when you get in, it's such a relief because you're weightless. So all of the prep of reading the charts and planning the dive and gearing up, it's worth it once you get in the water. And you can see that I'm wearing these really big dry gloves, and I have, warm winter gloves on underneath that. So it does take some getting used to use the camera and change the camera settings with those gloves on. And it's weird because you lose tactile senses with it. So if I need to grab that second regulator to change, or I need to unclip my vest, or I need to grab my knife or get in my pocket, you can't feel any of that. So I spend a lot of time in pools or on the shore practicing just reaching for things on my body, on my dive gear, because if there's ever an emergency and I need it quickly, it has to be muscle memory. You have to know where it is because you can't feel it. But even with those big gloves on, the limiting factor to any dive are the hands being cold. It's just your body trying to keep your internal organs warm. So if your hands get cold, it does become a safety concern. We just end the dive and get out. But I think it takes a certain personality type to be a polar diver. You really have to want it, and you have to be very confident. You have to be confident in your training. You have to be confident in your dive gear and confident in yourself and your ability to make judgment calls in the moment. You just have to be fully self-sufficient. But with saying that, we dive very conservatively. We are 2 days away from any medical help, so we don't like to push our limits. So we dive within all of the recreational dive limits, which is 40 meters or 130 feet. And our company policy for time allowance is 1 hour. And I usually try to stay for an hour just because I love it. And with the heated vest, an hour is pretty easy to do in that temperature. But it's not fun diving, like relaxing holiday diving like you would do in the Caribbean. It's very challenging, but for me, it's rewarding and it's worth it. I love being able to show people what lives beneath these really remote waters, because I think they are things and animals that would otherwise be left a mystery to people. And so I really like breaking misconceptions of what does or doesn't live in the Southern Ocean. So with that, welcome to my office and one of my very favorite places, the underwater world of the Antarctic Peninsula. And this is one of my favorite dive sites. You can see it's just beautiful. And that's me diving with my camera there. This photo was taken by my colleague. And I think a lot of people don't realize there's kelp in Antarctica, especially around the peninsula, which is quite far north. So we do have many different species of kelp. And on the surface of the water, you see all the seals and the penguins and the ice, and things are monochromatic. Everything's either black or white or gray or blue. But once you dip below the surface of the water, there's just this absolutely explosion of color. And basically anywhere life can be, it will be. And when I was talking about that dive planning, what I'm always looking for is a rocky surface. Because things can grow and hold on to rock really well. You will always find more life on a rocky environment than you will like a sandy bottom. And we want to find an overhang or a protected area. Because if you remember, I said that big tabular iceberg can go hundreds of feet below the surface. If that were to come by this piece of rock, it'll scrape all the life off of it. And we call that the ice scour zone. So what I'm always trying to find is somewhere free of ice scour. So in this photo, you can see more species of animal just in one picture than you will see in an entire week on the surface around the continent. And so, yeah, these are animals. People might think they're plants, but most things we're looking at are animals. So this is a sea anemone and sponges. There are some bryozoans. And there's a lot of stringy things you see around. Those are all different types of tube worms. So yeah, many different species, very abundant. And something I really like to see in Antarctica are the sponges. I find them very fascinating. And because, again, they are animals, even though they don't look like it, a very simple animal. But one sponge they found in Antarctica, they estimate to be 15,000 years old. I'm not kidding, that's real. It makes it the oldest living animal on Earth. But also the sponges in Antarctica are being used for medical research. Since they can't move to escape predators, they have chemical defenses they use for this predator here, like that sea slug. So they secrete these chemicals for defense, and people have been harvesting them and using them to treat things like MRSA. And they have found it to be successful, and they're trying to replicate those toxins and they're doing clinical trials with it right now, which is pretty cool to hear. And I just read a new paper that came out in 2019 that they're also trying to treat malaria with the toxins from sponges. So there's a lot of research still to be done. But in these cold waters, remember I said it's the coldest water in the world, it's able to hold more dissolved gases than warm water. So there's a lot of oxygen, a lot of carbon dioxide, and that's allowing tons of growth. So the animals that live here grow very slowly, but they grow to be very large and they live for a really long time. So this sea star here, it's not very big, maybe a little bit bigger than my hand, but it can live to be over 100 years old. That's the Odontaster sea star. I see it on every dive. It's one of the most common sea stars. And also because of this really oxygen-rich environment, we see something called polar gigantism. You also see this in the deep sea, which is a similar environment. So that just means organisms that we see worldwide, we see them similarly in the Antarctic, but they just get much bigger. So here we have a sea spider or a pycnogonid, and they live in all oceans, but usually a big one in other oceans might be, the size of a large coin. But in Antarctica, they can get to be dinner plate size, so much, much larger. I've never seen one that big, but hopefully. And another example of polar gigantism, this Labidiaster sea star, it can get 2 feet across, another favorite thing to see. And I'm going to show you a little bit of a video edit. I prefer to show videos actually than photos because I like to show behavior and I like to show the movement. I think there's a lot of misconceptions that invertebrate animals aren't very lively, they don't move, but they actually can be quite active. I wanted to show you more videos, but the PowerPoint couldn't take it. But I'm going to show you this little edit. So common scene as we're getting ready. Like I said, we try to gear up on the boats. I don't like to walk around with it too much. And I try to gear up very quickly so you don't lose any heat and get cold before you get in the water. And we just roll in. That's the best way to enter the water. And all that brown stuff underneath the ice, that's the phytoplankton. Diatoms is the most common species of phytoplankton down there. And you can really tell it looks brown. It's not dirt, it's just abundant growth, and that's where the krill will come to feed. The Southern Ocean used to have a huge whaling industry. It's ended now, but you still see remnants of that. These are whale bones. You can find different species, and now they're just acting as a host for different forms of life, but it does show you the scale of the animals. And we do see some fish, not very often. Maybe once a week I'll see a fish, but most of the fish in the Antarctic are part of the family Notothenidae. So they don't have swim bladders, they'll just rest on the bottom. They don't want to lose energy, and they'll just wait for a prey to swim by and ambush them. Mostly what we see are grazers, like these limpets, and that's mainly because of the ice scour. If things came and wiped out a community, these grazers can recolonize areas very quickly, so we always see them even in sandy bottoms or glaciated areas. We see different types of these grazers that can come back very quickly. And there's my favorite, the sea spider or the pycnogonid. Interesting to be able to watch it crawl and move its legs. But notice that appendage on the left side there in front, it's kind of clear. That's a proboscis, and it's actually using that to feed. So it'll jam it into soft-bodied prey like worms and suck up all the nutrients. You can see where that light is shining. That's the Labidiaster sea star, 2 feet across, so really big. can have 40 arms or more. And this sea star is really interesting because it's a predator of pretty large organisms. So what it'll do to feed is it'll stick its arms up into the water column, and there's tiny little hooks all over the outside of those arms, and they can capture prey that's as big as a fish. So they do capture krill, they eat fish, and no other sea stars go hunting fish like that. So these odontaster sea stars, they're not mating. They spawn to mate, so they are either fighting over food or sharing food. Their stomachs are on the underside, and they actually have two stomachs, and they will push one stomach out and put it over their prey and use digestive enzymes to break it down. So you can see those little globular things. That's its stomach on the underside. You see it has some food there. It's trying to break down, and it'll slurp up all the nutrients. So this sea star, you can see, is on the prowl as well. It hunts other sea stars. This is a high-speed chase. So it'll crawl right over the top of this smaller odontaster star, and it'll digest it with that stomach I just showed you. Here you can see the sea star moving after a snail. The snail touches its predator, panics, and I've only ever seen this once. It's really interesting how it's using its whole body out of the shell like that to escape. So watching these interactions is interesting. In this, I just want to orient you a bit. So this is a sea cucumber, and you can't see the body, but it's maybe 12 inches down the back. And all of these things around are tentacles, and they have a sticky mucus-like substance, and it sticks it out in the water column, and it captures any kind of planktonic prey, and it brings it into its mouth here in the center to feed. So you can see this sped up video where it's just capturing food and bringing it into its mouth. And of course, penguins, everybody's favorite. They don't fly in the air, but they certainly fly underwater. And they look really, they waddle on land, but not very elegantly, but they're absolutely beautiful in the water. And that just shows you they are marine birds. They are meant to live in the water. Yeah, I wish I could show you more videos. I find it so fascinating to be able to show predator-prey interactions like that. But that'll have to do for now. So when we dive within scuba limits, like I said, we can only go down to 130 feet. And oftentimes that's still in that ice scour zone. So we're just seeing a very small fraction of what actually lives on the sea floor. And so what lives below that? And one way we can find out is using remotely operated vehicles, or ROVs. That's what I'm holding there, that little ROV. And it allows us to get to deeper depths. So this is our setup. We take it out in the Zodiac, and you can see there's this computer set up. You obviously can't go if it's too choppy or if it's snowing, because that would get wet. So I have this little video edit. So our time lapse of setting up, those are the tethers. We have 1,000 feet, or about 300 meters of tether. So one end will connect to our computer. We have a remote control to drive it, and the other end connects to the little robot. And we have that generator that powers all of it. It's great because it's so portable, but that also means it's kind of small, so it does not do great in currents. This is the Video Ray Pro 4. So this is common as we're going down. You can see all the sediment in the water. That's because we're in areas with glaciers, so that's glacial sediment. And you can see the bottom's very silty. You see what I mean, that there's not as much life if there's not rocks, but there certainly is life. And you can see the currents just ripping down there, but all of these animals are well adapted to that type of environment. And again, those are animals, those things we are seeing. And this is a dragonfish. I love seeing these. I've only ever seen, I think, it twice. But they have special antifreeze protein in their bloods that allows them to live in below freezing temperatures. And what it does is if ice crystals start to form in the fish, the antifreeze protein will bind onto it and inhibit the formation of that ice crystal. So this is the depth went away, but this must be like 500 feet. So still outside of diveable limits, but you can see there's kelp down that deep, and those white sea whips sticking up, those are soft corals. So there are corals in Antarctica in the cold water. They're not the stony corals like you might see in the tropics, but there definitely are many species of coral in the deep polar oceans. So my take-home message showing you all this underwater life is that these Antarctic benthic animals, all of these invertebrates, they don't just survive, but they actually thrive in this seemingly inhospitable ocean, even with all the glaciers and the currents. So it's just really vibrant, abundant life. So for the future of Antarctic science, I really think we're going to start seeing more about it, hopefully in the media, but certainly within the scientific community, because Antarctica really is Earth's last great frontier and its last big wilderness area left to explore. And I know Australia and New Zealand just got big grants for funding for Antarctic research over the next 5 years. And the NSF in the US also has ongoing grants for research projects. And one of the reasons we really need to keep studying this ecosystem is because we don't even have baseline data for it yet. So there's still areas of this ocean that we don't really know anything about. We don't know if it changes throughout the year or if there's seasonal changes. And without these baselines in place, the scientific community can't predict how this environment will be affected by climate change or a changing ocean. So if we don't know what's going on in general in Antarctica right now, we can't possibly predict what the future might look like. And this baseline information is also really important regarding decisions making, allowances about fishing practices and making policies. So right now in the Southern Ocean, we do fish. We fish for things like toothfish and krill. And we've set allowances, but we don't really have enough data to confirm that these are the proper allowances. So yeah, we need to do a lot more research. We should also stop eating krill from Antarctica. So in general, Antarctica is a pretty fragile environment and it's becoming increasingly vulnerable. The peninsula region that I showed you, it has been warming 2 to 3 times faster than the global average, which is really scary. And if this trend continues, it's going to be extremely detrimental to all of the Antarctic wildlife. But it's not just about the penguins. I tell people, I start talking conservation and they think I'm really just concerned about the animals, which kind of true, but it's not just that. Because although Antarctica seems really isolated from the rest of the world, it's connected to the entire world through that Antarctic circumpolar current. Remember I said we'd come back to that current that circles the continent. So it's connecting all the world's oceans, and the cold water from the Antarctica is coming up and meeting the warmer water near the equator. And this mixture is absolutely the key link in our global conveyor belt. So if you remember from school or on all those maps you see with the current conveyor belt that goes around the world, it's controlling things like the atmospheric pressure, humidity, air temperatures, wind patterns, and all these things are really interconnected and they're greatly influenced by the Southern Ocean. It's also really critically to note that 90% of all of Earth's ice and about 70% of all of Earth's freshwater are locked up in that ice sheet on the Antarctic continent. So if that were to melt, and it is melting, it's starting to retreat, we see that happening, it's estimated that sea levels would rise about 190 feet or 60 meters. And those are not insignificant numbers. Anyway, so protecting this environment, it's not just about saving the cute animals. It's really for our own benefit and our own well-being. So my future in Antarctica, I always hope to continue to dive down there and to use underwater videography for outreach, but I'm really looking to move more to the research side of things. And like I said, I'm applying to different PhD programs right now. So if anybody watching this is taking on PhD candidates, let me know. I'm a good student. But what I want to do is study that benthic life, the invertebrates. I really love the invertebrate animals down there. But right now, the benthic sampling is largely restricted to the continental shelf, and very little is known about the fauna of the deep sea. So I really want to use some ROVs and do some biodiversity transects of the Antarctic deep sea benthic life. And then we can use that for baselines to judge future changes. Anyway, kind of in conclusion, I really wanted to do this talk because I believe that outreach is incredibly important. And as a population, we get to participate in things like choosing leaders who believe in climate change and prioritize protecting our wilderness areas. And sometimes things like petitions come around that all people can sign to do things like make new marine protected areas. And it can't just be us scientists who work in these areas fighting for their longevity. It really has to be everyone. We have to get everyone involved. So hopefully after this talk, you feel a little bit more connected to the Antarctic marine environment. And hopefully you feel inspired to be a good advocate for it. And you should probably go on Google and look up more things about Antarctica. It's very interesting. And just keep your eyes open and your ears open about things that are happening in the continent. Try to stay updated, and because our choices matter and our actions matter. And with that, I think I'll take some questions. So this is my website, saveourplankton.com. That's also, I'm a little bit biased towards plankton. That's also my social media handle. So on like Instagram and Facebook, I'm posting more imagery and videos of my work. So if you want to learn more, you can follow me there. And I'll hand it back to Christine to help with questions.
Thank you, Shaylyn, for this fantastic program. I found it incredibly interesting to watch the pictures and videos you were annotating with your expertise and experience. I really like the explanation of the rituals whales do to optimize their feeds of krill. It was very interesting and comparable to warfare. For folks like myself who have always dreamed to visit such amazing places like this, this appeased that desire. So I have a lot of questions. So I don't know how quickly we'll get through all of them. But the first one is, what are your chances of survival if there's an emergency?
It totally depends on the emergency. Yeah, it's hard to answer. Any kind of minor emergency we can handle. We're all trained in rescue diving, CPR, first aid. We do have a medical clinic on board the ship and a medical doctor with oxygen. So usually if it's a dive incident, the first thing you need to do is give a diver oxygen. So it really would just depend on the severity of the accident. I would be confident in my colleagues safely rescuing me from the environment, but yeah, it just depends on how your body handles any kind of trauma.
So leading on that question, I have a question about how often is the technology associated with the diving suit gear and suit updated, and what sort of safety protocols are involved with these updating processes? And do you get involved in them?
Yeah, it feels like it's updating all the time. I just bought my suit. It's been almost 2 years now, but they're very expensive. I paid, a custom fit suit's about $4,000. And people are like, oh, but you'll use it for a long time. But the reality is it'll go out of date, already. Basically, there's already newer models and better advances. But for the gear, you can continue using it. I've had my same regulators for many years. You just need to do regular inspections. I send it off to a dive shop. I don't do it myself, to get all the regulator checked and serviced, and my dry suit serviced as well.
So another question is, do you dive in nitrox or air?
We dive air. We have just a regular air compressor on the ship. So yeah, just compressed air. I would like to dive nitrox, but we don't have that.
So moving on, have you ever had any interesting encounters in water with leopard seals? I remember another photographer being presented with penguins alive and dead.
Yeah, so we are pretty careful about leopard seals. Early in the season, they're not as aggressive. Towards the end of the season, they get a little confident. I've never had a close encounter with them. I don't know if I'm lucky or unlucky, but I have seen them in the water, but they're often pretty timid. They don't know what we are. We're creating a lot of noise and bubbles. We're very foreign to them. So when I've seen them, it's just been in the distance, them kind of checking me out and then swimming away. But it's really interesting because you can hear them singing underwater. They have a very unique call. And so usually I can hear them and I start looking around and like, ugh. don't know how close it is, but you can hear it.
Could you explain a bit more about the risks and dangers of diving next to an iceberg?
Yeah, so, most of that iceberg, 75 to 90% of it will be underwater. And the part of the iceberg that's underwater is going to melt away faster than the top side portion of it. So as it's melting, it's eating away, the ocean's eating away at it, it becomes unstable and they will roll very quickly. There's not much warning, or there's no warning. They can just flip. I've seen it happen a lot. You get pretty good at reading icebergs and know how stable you can assume them to be, I guess. But they're big, they're heavy. It's a lot bigger than I am. And so if that rolls, I don't want to be anywhere near it.
What is one luxury or treat that you miss the most when being gone for so long diving in the Antarctic or the Arctic?
One thing I miss the most, sleeping more hours. I actually love being on the ship. I love being in these places. It's hard. They're really long days. We're up at like 6:30 and it takes a lot of energy to dive in these waters. So if I've been diving that day, I'm just exhausted. And then I still have, a full rest of the day to do, and driving boats and giving lectures and, prepping for the next day. So the days are really long. So I guess I just miss, more sleep.
So how is communication at the poles? Like, for example, how do you communicate with your friends or family while you are away for extended time?
And so we actually, on the ships that I work on, we have internet. So high tech, not very good internet. I mean, we're in Antarctica, so you can't expect too much. It's pretty slow to load. There's a lot of applications that can't work. Like I usually can't load like Instagram photos. The bandwidth's too big. But I can receive emails and usually text messages. So we are able to stay in contact. We have phones if there's ever emergencies. But yeah, technology. It's incredible.
How would a student who's interested in getting into this profession, what would be your recommendations to them?
Well, to do what I'm doing, you definitely need a degree in the sciences. And dive training. So to be any type of professional diver, you'll need to be at least a dive master. And what I found to be the most useful is just trying to make connections, which is difficult to do if you're not in the industry initially. But I just say reach out to people, email people, just tell them who you are. The worst they can do is say no or just ignore your email. But I still do that. I'll still just find somebody I want to work with or something I want to do. And I just send them an email, tell them who I am, that I'm really interested in their work. And it is successful. That is, I think, the thing that I found to be most helpful in this industry.
And lastly, IMarEST has a working group trying to get more women involved in the marine sciences. How many women peers do you have? And do you find that it's a disparity between women and men? What are your thoughts? Open mic.
Yeah, diving is still definitely a male-dominated field. I like being a woman in the field, kind of pushing those boundaries. And dive gear is finally coming around to fit women. I had to get my custom suit because for a long time they just had men's suits. So I did spend my first season, I think, with this company. I was diving in a men's small. And they were like, "Oh, you said small," and I'm like, "A men's small? That's huge." So it is still a male-dominated field, and the hard part with that is the gear is so heavy that just physically the men do a lot better carrying it around. They are less fatigued. They don't get cold as easily. It's not really fair when I'm diving with my male colleague who's twice my size, and he's like, "Oh, it's nice temperature," and I'm freezing. But I do find it to be a field that's really open and inclusive for women. All of my male colleagues have been incredibly supportive. Yeah, I get comments from guests sometimes about if I'm driving a boat, women driving boats, and but overall, there are more women entering the field sciences all the time, and hopefully we'll continue to see that happening. But luckily, yeah, my colleagues and the company is very supportive of that.
Well, thanks. That sounds like a great area for people who want to expand the technologies, specifically about the temperature loss. Just need to change the technology, and yeah. Well, great. Well, I thank you so much for your time and your expertise, and thank you so much for sharing it with our community. I know that people all over the world have been watching, and I'm so glad that you left your connection so that people can email you questions or connect with you. And I ask more questions if they have more interesting topics to talk about. Thank you so much. And thank you everybody from around the world who has been watching. And I think that's the end of our presentation.
Yeah, thanks for having me, guys.